All right. So a user sent us this query and asked for some help to optimize it. Because if I run this on large, you can see it takes a while. All right. So having run this now, I waited for 107 seconds. I spent 100 credits, which is a lot more than 20 on the old engine. But yeah, there's some other interesting stats here that I wanted to get into. So this seemingly simple query actually goes out and it reads almost a terabyte of data from Dune's data platform. It then uses 6,384 seconds of CPU, meaning that the effective parallelism here is something like 60 CPUs running for a full 107 seconds. So this is a long time, and it's directly correlated to the amount of data that we're reading. So if we know a little bit about the data that we're looking for or the underlying data sets, we can actually do a lot better. So one sort of evergreen trick that I'm going to show you is simply just selecting the columns that you want. This is not the most effective trick I'm going to show you, but it can be quite effective. So I'm just going to select hash and maybe the blockchain. These are two columns. I'm going to save and run. Be right back when this is finished. All right, so we're back. Now the credit cost is down to 53 credits. And you can see that we reduced the amount of data that we read from 900 to 600 gigabytes. So we shaved off about 1/3 of the data and about half of the credit cost just by selecting the columns that we need. Now, if we, as the sort of SQL querying user, know a little bit about the data, we can be a little clever. So, for instance, here maybe we know that this address that we're looking for is only ever active on BNB. Now we can filter to only select from the BNB blockchain. Now this is going to be effective because this particular table that we're querying is actually a view on top of Ethereum transactions, BNB transactions, etc., etc. So by specifying blockchain equals BNB, we can actually skip reading a lot of data. All right, now this is finished. We're down to 10 credits, so half of what a large execution used to cost. We're only reading 160 gigabytes of data here, and we're only using 675 CPU seconds. Now, this trick I'm going to show you now is also unreasonably effective across almost every data set on Dune, and that is adding a filter on the block type. So if you can do this, it will be the single most important thing to drive down credit costs and compute times. So in this particular case, maybe I'm only interested in querying for the last month of data. If I run this, we'll see that this is quite fast. All right, now we're down to 0.72 credits. Took 3 seconds to run, and we were only scanning 9 gigabytes of data. So by adding some filters and only selecting the data that we want, we can effectively decrease the credit cost of this query by 100x.